All right, so we are going on YouTube, and this is the first question. So, how do we answer this question? So many different ways. If you remember some identities from the class, you can use them. If not, then you use what I taught you how to do. You can take the derivative to get rid of the k you have below and then see what happens. So first of all, you would see here that f of 0 is equal to 0. Why is that? Because k goes from 1 to infinity and x to the power k is 0 when x is 0 for any k larger than 1. That's why f of 0 is 0. Now, f prime of x, if I just take the derivative, it's going to be sum k from 1 to infinity of negative x to the power k minus 1. K goes down and cancels with this k. And then chain rule, you take the derivative of minus x, that's minus 1. So this is equal to minus sum k from 1 to infinity of negative x to the power k minus 1, right? Therefore, we obtain that f prime of x equals negative, and this sum, what is it equal to? With k equal 1 to infinity, and the power is k minus 1, this is same as sum k from 0 or n from 0 to infinity, negative x to the power n, where n is replaced, where k minus 1 is replaced by n. Therefore, f prime of x, this sum is 1 over 1 minus x, which is 1 over 1 plus x. So you get that the derivative of f of x is negative 1 over 1 plus x. So this comes from that. That's where you get this. Therefore, you can integrate now, get f of x is negative integral of dx over 1 plus x, which is negative natural log of 1 plus x, plus a constant. F of 0 is equal to negative natural log of 1 plus c, which is c, and f of 0 is 0, so c equals 0. So the function in this case is nothing but negative natural log of 1 plus x. Questions? Is there any question? All right, so let's look at number 2. And problem number 2 was also identify f of x and was represented as a power series as well. And the power series this time was sum k from 1 to infinity of k times negative x to the power k. And so that was technically stacking the first problem and removing k from the denominator and put it as a numerator. And in this case, what will happen is that this function f of x is equal, if we get one of the x's out, that's x sum k from 1 to infinity k times negative x to the power k minus 1. This is what you get. Why am I taking that x out and then keeping the minus 1 here? okay? Because I'm taking x out, but it was negative x. So I'll keep the negative 1 here, half k times negative x to the k minus 1 to keep this form, which is the derivative of negative x to the power k. This thing inside there, the whole thing there, is the derivative of negative x to the power k, which is what I actually obtained here. That's it right there. We got it here. Because we just cancel the k. K cancel with this one to get that. That's why you have this. That this thing here is the derivative of negative x to the power k. So this thing is x, then sum k from 1 to infinity of negative x to the power k, then take the derivative, which is same as x, then sum k from, I can take 0 to infinity, negative x to the k, negative x to the k, then take the derivative. All right, equal to 0, it's 1. The derivative of 1 is 0. So I'm adding k equals 0 here to make sure that inside that I have a sum that represents the sum of the geometric series, which is 1 over 1 minus r, right? So I'm adding that term, but I know adding it doesn't change anything because I'm taking derivative, and the derivative of that constant that I just added is 0. So I have not changed anything by making the sum start by 0 because I got derivative on top that makes it 0. Am I making myself clear here?
Yes.
And so when you do that, this is x, and that sum inside there is 1 over 1 plus x. Again, that same 1 over 1 plus x that we had in the first problem. And the derivative of this is negative 1 times x over 1 plus x squared. That's it. Any questions? All right, that's it. That's what the first 2 questions were about. Now, let's go to the third. So question number 3. Sketch and find the area enclosed by one loop of the curve r equals 1 plus cosine of 4 theta. Sketch and find the area of one loop. All right, so 2 things that I ask you to do for this question is, first is solve r equals 0. R equals 0 gives you 1 plus cosine of 4 theta equals 0, or cosine of 4 theta equals negative 1. And that means 4 theta. The angle with cosine negative 1 is pi. There is no other one. So that's pi plus 2k pi, where k is an integer. So that leads to theta equals pi over 4 plus k pi over 2. So those are all the angles where the radius goes back to 0. And then you can list them. You can have the angle would be pi over 4 when k is 0, then pi over 4 plus pi over 2, which is 3 pi over 4, when k is 1, then pi plus pi over 2, 5 pi over 4, when k is 2, and then k is 3, then, and there you will have 6, 7 pi over 4, when k equals 3. And when k equals 4, you return to the first point. So these are all the points that you need where the radius goes to 0. 1, 2, 3, 4 points. And when the radius goes from 1, 0 back to 0, it forms one loop. So one loop could be considered right here, from pi over 4 to 3 pi over 4. Another one could be considered here, from 3 pi over 4 to 5 pi over 4, or from 5 pi over 4 back to 7 pi over 4. Now the second thing was to solve r prime equals 0, to know when the angle reaches the max, when the radius reaches the maximum or the minimum. When r prime equals 0, in this case, that's -4 sine of 4 theta equals 0, which leads to 4 theta. When the sine is equal to 0, is k times pi. So that leads to theta equals k pi over 4. Are we good? Now here what happens. When we got theta, and then we got k. When k equals 1, when k equals 0, you get 0. So that's the first point. When k equals 1, you get pi over 4. When k equals 2, you get pi over 2. When k equals 3, you get 3 pi over 4. When k equals 4, you get pi. K equals 5, you get 5 pi over 4. K equals 6, you get 3 pi over 2. When k equals 7, you get 7 pi over 4. And when k equals 8, you get 2 pi, which brings you back to 0. So you actually have 1, 2, 3, 4, 5, 6, 7, 8. You have 8 points where the radius goes back to 0. Sorry, when the radius reaches potentially the maximum or the minimum. Now we can draw. The radius is 0 at pi over 4. At 3 pi over 4, the radius is 0, and 3 pi over 4 is on that side, right? So we are assuming that we'll be thinking at pi over 2, you get 2 pi, and so R would be 4 times pi over 2 is 2 pi. Cosine of 2 pi is 1. 1 plus 1 is 2. So this crosses this line at 2. And from pi over 4 all the way to 3 pi over 4, there is no point where that derivative is equal to 0. It's going to be 1/2 Hello?
Hello.
Yeah, can you hear me?
Yeah, we can hear you.
All right. I think I had an issue with the connection. I don't know why. All right. So this is what we would do. And now you can square this. So that's 1/2. And pi over 4 to 3 pi over 4. 1 plus 2 cosine 4 theta plus cosine squared 4 theta d theta. And this is 1/2. Integral from pi over 4 to 3 pi over 4 of 1 plus 2 cosine 4 theta plus, and then cosine squared can be replaced by cosine of double angle plus 1, so that be cosine of 8 theta plus 1 over 2 d theta. This idea for the integral. So 1 plus 1/2, that's 3/2. So you, and then you have 3/2 theta plus 1/2 sine 4 theta. And then you integrate this one, you get plus 1/16 sine 8 theta pi over 4 to 3 pi over 4. When we plug in 3 pi over 4, we get 9 pi over 8. Three pi over 4, sine here gets 0, sine here gets 0. Then minus, when we plug in pi over 4, we got 3/8. And then you plug in sine is 0, you plug in sine is 0, so the answer is 6 pi over 8, which is 3 pi over 4. So that's the area. Any questions? All right. Next. Question 4. Find the limit using Taylor series. Limit as x goes to 0, sine x minus x over 2 e to the x minus 2 minus 2x minus x squared. All right. If you want to find that limit, the first thing you want to do is to find the Taylor expansions of each of the functions that is there. Sine x is x minus x cubed over 6 plus something. So sine x minus x is negative x cubed over 6 plus something. E to the x is 1 plus x squared over 2 plus x cubed over 6 plus something. So 2 e to the x minus 2 minus 2x minus x squared is equal to x cubed over 3 plus something. Therefore, sine x minus x over 2e to the x minus 2 minus 2x minus x squared equals negative x cubed over 6 over x cubed over 3 plus dashes, and this is almost negative 1/2 a limit when x goes to 0 of sine x minus x over 2e to the x minus 2 minus 2x minus x squared is nothing but negative 1/2. Then you had question 5. Find all points where the tangent is horizontal. For r equal cosine theta. So first of all, you got x of theta, r cosine theta, and that is cosine theta, that's cosine squared theta. Y of theta, it's r sine theta. X equals x. It is derivative sine, it's cosine. That's squared minus derivative of sine, so that's minus sine squared theta, divided by x prime, derivative of cosine theta, that's 2 cosine theta, sine theta with a minus sine. And this thing is equal to 0, where the tangent, where the tangent line is horizontal, the slope is 0. So you get cosine squared theta minus sine squared theta equals 0, which is cosine 2 theta equals 0, which leads to 2 theta equals pi over 2 plus k pi, any such point. And that leads to theta equal pi over 4 plus k pi over 2. Those are the different points that you would have. And that gives you, when k is 0, pi over 4, then k is 1, you get 3 pi over 4. Then k is 2, you get 5 pi over 4. Then you get k equal, this is 0, 1, 2, then k is 3. So you get 6, 7 pi over 4. Then you get k equal 4, and you get back to the first point. So you have 1, 2, 3, 4 points. And for each of those points, you get x and y. When you get pi over 4, you get x is cosine square of pi over 4. Cosine square of pi over 4 is 1/2. And cosine theta is sine theta. What is it? That'd be 1/2 as well. Cosine pi over 4 times sine pi over 4, it's 1/2. Then theta equals 3 pi over 4. Cosine square is again 1/2. And y, cosine times sine. The cosine is negative, or 3 pi over 4. And the sine is positive, so that's negative 1/2, the second point. The third point, with 5 pi over 4, both the cosine and the sines are negative. And what's going to happen here is cosine squared theta is going to be 1/2. And sine theta, cosine theta is going to be 1/2. So the point that you get here is the same point that was at the beginning. And then you have the last point here, where the sine is positive, is negative, but the cosine is negative. You get the second point of this guy. So you get 1/2, negative 1/2 there as well.
I have a question.
Any questions? Yes.
Could you scan the notes? Because your internet is very spotty and it's like doesn't focus on the paper a lot.
You don't see what I have written?
We do. It's just like a lot of the times it like unfocuses, so it's very blurry.
That is strange. Because I can see it clearly. Is that same for everybody?
It's a little blurry for me too.
Yes.
Because I know I've changed the contrast, but I didn't see. How about now?
I don't think it has anything to do with the camera. I think it's more of a internet connection thing.
Oh, I see. All right. Yeah, it should be the connection. So, was it like that at the beginning?
At the beginning, it was fine, but when you got cut out, it started getting pretty blurry.
From my to another one because my main internet source got off because of the energy. So it's actually a backup that is running now. Unfortunately, those are the issues that I have here. All right, so we had question 5 to go. No, that was question 6 now. So find the slope of the tangent line at the point t equals 1. Actually, putting this question, I thought that it is the question that everybody was to get all points on. So x of t is 1 plus t squared. Y of t is arc tangent of t. So x prime of t is 2t, y prime of t is 1 over 1 plus t squared. So m is y prime of t over x prime of t, which is 1 over 2t times 1 plus t squared. And then m of 1 is 1 over 4. That's all. Same for question 7. Find the equation of the line. A, negative 1, 1. B, negative 2, 4. Equation of the line. Of course, this is what the only equation we went through was the parametric equation. So this is what that was about. So x of t is xa plus xb minus xa times t. Y of t is ya is yb minus ya times t. T negative infinity to infinity. And I emphasize this is important for that to be the equation of a line. So you get x of t, xa given minus 1, xb minus 2, minus 1 plus 1, t, y of t, y of b is, y of a is 1 plus YB is 4 minus 1t, and that is minus 1 minus t, and this is 1 plus 3t, negative infinity less than t less than infinity. That's it. That's the end for the test. Any questions? Is there any question on this topic? All right. So please. Now I'm back, but we might run into an issue because the computer is showing that's going to shut off at any time. But I'm trying to get a generator to work so that we can continue the lecture. Unfortunately, that's what happens. And someone is there trying to run the generator now for us to be able to have the energy to run the computer. Now, what I wanted to talk about after this test was just some few topics on the vectors in space. W. So last time I introduced the definition of some vectors, which is what we use actually to write the equation of a line. And now I just wanted to go through these questions that you have as application of today's lecture. So here we want you to be able to know what represents a vector that goes from one point to another. It is, say, a vector that has its origin at the first point. Like here, OE is a vector that starts at the point O here and ends at the point E. So it starts at the point O and it's drawn to the point E that is up there. This first question says, for example, refers to this graph and write this vector as a sum of scalar multiples of u and v, where u is the vector along the side and v is the vector along that side. So you have to see how many of such vectors we need to add to get to E. So to go from O to E, we could go from O to all the way to this point here, and then go from this point to E. Now from O to the point here, you have 3 times U, because this is U, this other one is U, and that third one is U. So you will have 3 times U, and then you have V, and then another V, then another V before you reach the point E. So to go from O to E, we got 3U plus 3V, and that's what is expected of you here, to say how many things you get there. That could be 3U plus 3V. So that's technically what you're expected to do there. Just count, go through the vectors, and try to figure out how many times you need to add to get where you need. So then, the same kind of question is what you have on question number 2. They want to see if you can recognize the vector that is drawn. You have a point P with coordinates 0, 0, Q with coordinates 8, 6, and you need a vector from P to Q. You know that the origin of that vector should be P, so it points starting from P. So you look at the options that you have and you look at the vectors that start at P. Which are the ones? So A, B, C, yes, A, B, C start at the origin, which is 0, 0. That's good. Now you look at Q. Q has coordinates 8, 6. Both 8 and 6 are positive. So the vector that you're looking for should point in the positive direction of X and positive direction of Y. And that's the only one, because this one points in the negative X, this one points in the negative X. So the only possible answer is that one, because it points in the positive direction of X and Y starting from the origin. Am I making sense? Now, the second thing in that question is compute the magnitude of the vector. How do you compute the magnitude of a vector? The magnitude of the vector is the square root of the sum of squares of their coordinates. So if I'm asked to find the magnitude of a vector, U, which is U1, U2, U3, or just U1, U2, then the magnitude of U is square root of U1 squared plus U2 squared plus U3 squared. That's how you would find it. In the given question that we had there, the magnitude of U would be square root of 8 squared plus 6 squared. 8 squared is 64, and 6 squared is 36, and this is square root of 110. So the correct answer in that question would be 10. So here, you would come and put 10 as the answer. All right. So that's how it goes. And here are more similar things that just need you to compute the coordinates. When you compute QU, PT, and RS, you would see the coordinates. The vectors that have the same coordinates are equal. If the coordinates of the vectors are same, then they are equal. That's what this question Connection was lost. Just got back. Thanks for staying. Now I'm trying, but there we go. So I think we are going to have a better connection now that it's back to the main line. Let's be reset back to the problem that we were trying to solve. Okay, here's the problem that we have. Can you guys see my screen?
Yes.
Yeah. All right. So this is one of the applications of vectors. For example, you can have a set of a mass. You have a mass of 600 pounds that is hanging on two chains. And the question is to find the force that applies on each of the chains. All right. So here is the graph with the forces that you have. If you have an angle of 60 degrees around here and there, then the same angle will be reported down here on the graph here. That's the same angle that you have on top there. On this side as well will be the same angle. And so the first question here would ask you which of A, B, C through D is the correct statement that you need to have. And the answer is, it is B in this case because we are applying the theorem that the sum of external forces is equal to 0 for a solid that is at equilibrium, that is not moving. When the solid is not moving, the sum of all forces that is external to it is equal to 0. And those forces here are F1, F2, and F3. It doesn't matter in what direction it points. That's why here the answer should be F1 plus F2 plus F3 equals 0. Also, you can say it's Newton's second law of motion, which states that the sum of external forces is equal to m times the acceleration. Because in this case, there is no motion, that it's equilibrium, the thing is not moving, so the acceleration is 0. So you get that sum of the forces is equal to 0. F1 plus F2 plus F3 equals 0 shall be the correct answer. Does that make sense? So it's one of the applications of the vectors. So here the question is, what is the force that each of these chains must be able to support? So what is F1? Technically, that means what is F1, what is F2. And the reason why you just have one spot here is that the angles being the same, the two forces will end up having the same magnitude. How do we find them? How do we find the two forces that are there? Now let me answer the question on the paper here. So we have the forces. Let's say here is F1. And you got F2 and the force F3 that goes down. This is F3. That's F1. And this is F2. Now there is a horizontal line there, and they say the angle here is theta. Same angle here, theta. So to answer such questions, what you need to do is to think of these lines as the axis X and the axis Y. And then you decompose the vectors on the axis. You say along the x-axis, what happens? How many forces are there? You must have Fx, F1x plus F2x plus F3x equals 0. So the sum of the forces along the axis x should be 0. Now along the x-axis, what are the forces that you have? For F1, you have F1x, that is here. The component that is here is F1 times cosine of theta. Why is that? Because when you close here, this is the right angle here. You have a right angle here, and therefore the cosine of theta is F1x over F1. Therefore, F1x is F1 cosine theta. And F2x is F2 cosine theta as well. That's why I said earlier that you are going to figure that F1 is equal to F2, that the two forces on the chains are equal, and that's why you have only one spot. Now, when you go along the y-axis, you have F1y plus F2y. These two forces are going up, and the third one is coming with a minus F3y equals 0. Why minus? Because F3 is pointing down. It's in the opposite direction of the positive y, so the scalar value is negative F3, though the magnitude is F3, but the scalar magnitude, the scalar value along the line is negative F3y. So here it's negative F3, not F3y, right? Because F3, all the vector is along the line, the y-axis. It comes with the minus because it's in the opposite direction of the axis. Now, F1y is F1 sine theta. F1y, it's that side. Sine of theta is F1y over F1. So F1 sine theta. And it's same as F2y because we got F1 equal F2. So what is going to happen is that you got 2 F1 sine theta equals F3. So F1 is F3 over 2 sine theta. And in the problem, it is given that F3 is 600 pounds. In this case, F3 is 600 pounds. Theta is 60. And the sine of 60, how much is that? What's the sine of 60 degrees? Which is pi over 3. Can anyone help? Hello? Can you guys hear me?
Yeah, is it root 3 over 2?
Yeah, it's root 3 over 2. So you get F1 equals 600 over 2 root 3 over 2. So that's 200 root 3. That's it. And so that's the answer that you need to put in there. Any questions on this? All right, so that's it. That's how you find that you get 200 root 3 pounds in the question. Now, the other question I had there was use the properties of vectors to solve. The operation 5x equals u would lead you to x equals u over 5. And the way you divide a vector by a number is you divide each of the components by that number. So u is -3, divided by 5, and y is 1 divided by 5, and that should give you the answer to the question. So technically, this is showing you how you divide a vector by a number. Now, what's happening in the next one? So you have a sum of scalar multiples of vectors. How do you add scalar multiples of vectors? The way you do that is you multiply each of the vectors by the scalars, and then you add component wise. That's what you would do. Okay. Now, this is an important question that shows up most of the time in your applications. You have a vector, and the question is asking you to find a vector of a different magnitude that goes in the same direction. So find a vector in the direction -7, 24 with length 2. How you do that? So let's get back to the paper here. How do you do that? How do you find a vector in the direction -7, 24 with length 2? Step one is you find a unit vector. In that direction. So you find a unit vector in the direction that is given. How do you find the unit vector? You take u and you divide by the magnitude of u. This shall be the vector, the unit vector in that direction. So u is -7, 24. And you divide that by the magnitude of u, which is square root of -7 squared plus 24 squared. Okay? And that's how you would go about finding the unit vector. And now you can add these things. And then in your second step, you need to multiply the unit vector by the given length. So in this case, it's 2. So you're going to have 2u over magnitude of u. So which is 2 -7, 24 over square root of 7 squared plus 24 squared. Because I'm not using a calculator, I'm just going to write down what that is. So this is -14, multiply 2 by -7, divide by square root of 7 squared plus 24 squared, whatever that is. 2 times 24, that's 48 over square root of 7 squared plus 24 squared. So you divide the same way you multiply, divide each of the components by the number, multiply each of the components by the number. So this is a vector of length 2 in the direction -7, 24. Any question? Thank you. If there's no question, again, sorry for what's happening, and hopefully next week I will be back to US already if I'm not stopped at the airport. And I'm traveling back on Friday after class, and I shall be there next week. Thank you for today. If there's no question, I'll see you on Thursday.
Thank you, Dr. Longwell.